Alright, so this section is about matrix inverses, so finding the inverse of a matrix and what that looks like. So let's start with the definition. Alright, so let's say we have a matrix A. So A is an n by n matrix, so this is a square matrix. C is the inverse of A if A times C equals the identity and C times A equals the identity. All right, so notice a couple things here. When we're talking about matrix inverses, we're only talking about square matrices because we want the multiplication to work in both directions. So remember, depending on the order of multiplication, you may get a different answer. But if you do both orders and still get the identity matrix out, then we can say these two matrices are inverses of each other. All right, and so we will denote it as C equals A inverse. And if you can find the inverse of a matrix, then you call that matrix invertible. All right, so you often hear the word invertible. So we're talking about invertible matrices. All right, so let's look at some examples. All right, so we have a matrix A. This is going to be a 2 by 2. Down the columns, I have 1, 0, 2, 3. And then C, down the columns, also a 2 by 2, 1, 0, negative 2/3, 1/3. So these are two matrices, and I just want to show that they are inverses. So to do that, I am going to multiply them in both directions. All right, so I'm going to start with A times C. All right, so when I multiply them, so remember going across and down, 1, negative 2/3 plus 2/3, 0, 3/3. We get the identity matrix in one direction, so we have to make sure that we get it in the other direction. So we're going to do C times A. Okay, so multiplying using our cross and down method. All right, so because we multiplied in both directions and got the identity matrix, the 2 by 2 identity, both times, we say that A is invertible and C is A inverse. All right, so let's do a theorem. So it turns out when we have a 2 by 2 matrix, it's very easy to find the inverse of a 2 by 2 matrix, and later we'll talk about how to find the inverse of other matrices. But we have a theorem for this. We want to let A be the matrix A, B, C, D. Then we have something called the determinant of A, which we will learn in Chapter 4, details about determinants. So I'll write this here. This means the determinant of A. All right, so the determinant of A, where A is a 2 by 2 matrix, is we're going to multiply the diagonals, multiply down the diagonal, subtract, and multiply across the other diagonal. So AD minus BC. All right, so if the determinant is not 0, that's good for us. So if the determinant of A does not equal 0, then our matrix A is invertible. And we can actually define the inverse. A inverse is going to be 1 over AD minus BC times, so note, 1 over the determinant of A, and then for the matrix it's multiplied by, what we're going to do is we're going to switch the first two diagonals. So the D is going to go in the top corner, the A in the bottom corner, and then we're just going to make the other two diagonals negative. All right, so this is the formula for the inverse of a 2 by 2 matrix. All right. If the determinant of A equals 0, well, what will we be doing? We'll be dividing by 0, and we can't do that, so we would not be able to find the inverse. So if the determinant of our matrix A is 0, A is not invertible. So before trying to find the inverse of a matrix, we should always make sure that it's possible to be invertible. All right, and so this theorem works for 2 by 2 matrices only. Okay, so let's look at an example using this theorem. All right, so let's say we have a matrix A. It's a 2 by 2. Down the columns, I got 1, 3, 2, 4. And we want to find A inverse. All right, well, based on the theorem, in order for it to be invertible, the determinant should not be 0. So let's find the determinant of A first. Remember, multiplying across the diagonals and subtracting. All right, -2 does not equal 0, so that means this 2 by 2 matrix is invertible, and we can find the inverse. So that means A inverse is going to be, using the formula, 1 over the determinant times this matrix, where I'm going to switch the first diagonal and then make these other two negative. And so I just need to multiply each individual piece by a -1/2. All right, so this is our inverse of this original matrix here.